Interkal is a registered provider with the American Institute of Architects Continuing Education Systems. Credit earned upon completion of this program will be reported to CES records for AIA members. Certificates of completion for non-AIA members are available on request. This program is registered with the AIA CES for continuing professional education. As such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA of any material or construction or any method or manner of handling, using, distributing, or dealing in any material or product. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation. Interkal is proud to present this AIA continuing education course on telescopic spectator seating. This program is registered with the AIA CES for continuing professional education. Questions will be addressed at the conclusion of this presentation. The course is designed to address the three aspects of architecture: health, safety, and welfare, HSW, as they relate to telescopic seating systems. The course covers telescopic seating systems, design considerations, bleacher types such as wall attached, recessed, reverse fold, freestanding floor attached, and mobile bleachers. You will learn about common seating surface options. We will discuss applicable codes pertaining to aisles and ADA requirements. We will cover required and optional accessories, such as aisle rails, intermediate steps, end rails, back panels, and back rails, vinyl side curtains, power systems, and backrests. You will learn some basic components of the bleacher understructure, and we will point out important considerations for coordination with other trades. At the conclusion, we will review the main points and answer any questions you may have. We begin with a glossary of terms to help you become familiar with specific references made throughout the course. Following is a glossary to help familiarize you with terms commonly used in describing bleacher components and attributes. Rise per row. This is the vertical dimension from seat top to seat top or deck to deck. Multiple standard rises are available. Increased rise provides a better and more comfortable seat height and better sight line. Row span. This is the horizontal dimensions from front of seat to front of seat. Typical spans are 22-inch, 24-inch, and 26-inch depth for bench bleachers. Wide span depths of 30-inch, 32-inch, and 33-inch are available for VIP seating options. Extended dimension. This is the distance from the wall or back rail to the front of the first row of seating with the system in its fully open position. The overall clear dimension will include the code-required first step. These dimensions will vary by number of rows, span, and wall obstructions. Stack dimension. This is the distance from the wall or back rail to the front of the first row when the system is retracted or stacked. The stack size will vary if wall obstructions are present or with higher row reverse fold systems. Seat height. This is the height from the top of the seat to the deck surface. Section. A section encompasses the deck assembly, seating options, and understructure that are the three major components of a bleacher system. Standard section lengths vary up to 26 feet, depending on number of rows and the bleacher type. Tapered sections. Used in radius corner applications, a tapered section is essentially a standard section with angled ends. This may be used with wall-attached, freestanding, recessed, or mobile units. While this option adds costs and complexity to the project, the use of tapered sections provides optimum sightlines and can produce a dramatic arena feel to the installation. The general guidelines and limitations to tapered sections are: Number 1. Even row alignment requires equal angles between sections. Number 2. Maximum angle of 22.5 degrees. Number 3. The first row length is required to be a minimum of 5 feet 0 inches, or quarter the length of the last row, whichever is greater. Bank. A bank is comprised of a number of structural sections grouped to function as one group but not necessarily tied together. Bank lengths can vary from 16 feet to several hundred feet. End rail. End rails are located at bank ends of seating that are not located adjacent to a wall. All current building codes require end rails in this application. All end rails are designed to not allow a maximum 4-inch sphere clearance requirement and also contain vertical members to eliminate ladder effect. Operating clearance. Referred to in two ways: 1. The operating clearance between sections. On manually operated banks, space is required between sections to assure adequate operating clearance. This helps eliminate binding and damage to the system if sections are not opened in straight alignment. And 2. The operating clearance to the side wall. This is the space required between the end of sections or rails and any wall or obstruction. In case sections are not opened in a straight alignment, this helps eliminate binding and damage to the system. The space required varies by number of rows and type of operation, but never exceeds the maximum 4 inches required by all building codes. Aisle rails. Aisle handrails are required by all current building codes. They are located in the center of each dual-access aisle and are available in several types, which will be discussed later in this program. Intermediate steps. Intermediate steps are also required by all current building codes. They are provided to create a safe walking surface by providing an equal depth and height step at all aisle locations. Section 1. Design. Section 2. Bleacher types. Section 3. Applicable codes. Section 4. ADA provisions. Section 5. Optional accessories. Section 6. Understructure. Section 7. Coordination with other trades. And Section 8. Review. Section 1. Design. The design process when planning telescopic seating for a facility starts by determining available space. Consider the length of clear space and depth available. The available length for telescopic seating is determined by the building design and location of doors, wing walls, and other wall obstructions, such as columns, pipes, and heating units. The following drawings show examples of typical applications such as banks of seating between door openings, banks of seating between permanent wing walls, banks of seating in wall-to-wall applications. Depth is determined by span per row and number of rows. Typical spans include 22, 24, 26, or wide deck platforms 30, 32, 33. Available depth clearances in a gymnasium are typically governed by the wall-to-court line clear dimension. Coordination with the end user on the amount of clearance from the extended bleacher to the court line is an important item for you to discuss with your client. Check with local governing agencies for recommended minimum clearances at both side court and end courts to ensure optimum safety code compliance. Locations of doorways on the side walls will affect the bleacher depth. Please coordinate these locations with the bleacher extended dimensions. Identify height restrictions in order to determine rise per row such as 10 1/4, 11 1/2, or 16 inch. Consider whether balcony access is required and plan for any obstructions such as basketball backboards, columns, door openings on side walls that may need to be accessed at all times. Other characteristics of the gymnasium, such as protruding pipes and heat registers, need to be taken into account. Proper row rise, the vertical dimensions from seat top to seat top or deck to deck, is important to achieve adequate sight lines. Multiple standard rises are available and increased rise provides a better sight line. 11 1/2 or 16 inch rise is recommended for optimal sight lines on balconies. Less than 11 1/2 inches rise does not provide wide scope vision of the main floor activities. If balcony access is required, the rise per row will vary depending on the number of seating rows that will be provided. Careful planning of the number of rows, span per row, and rise per row is required to fit into the available depth. As an example, if a row must be added to achieve access into a balcony, the overall depth of the bleacher will increase and may push your bank of seating too close to the court line. There are several options available to achieve a smooth transition into the balcony. Options shown here include alternate standard rises, closure board access, extended closure access with additional step. A custom rise can be provided if all of these options shown do not work in your application. A custom rise for telescopic seating is very expensive to engineer and manufacture. For that reason, they should be the option of last resort. Certain building codes allow for an uneven transition to adjoining construction if the steps are highlighted with contrasting color strips. Be sure to provide for adequate clearance of obstructions. Overhead obstructions are items such as side court backstops, lighting, building truss and ductwork, overhead clearances for backboards, light fixtures, acoustic panels should be out of reach of spectators when they are standing on the bleachers. Look for and dimensionally locate any doors, windows, pipes, ductwork, drinking fountains, columns, electrical boxes, conduit, cross bracing, floor or wall vents, divider walls or curtains, wall pads, fire extinguishers, switches, and outlets, including sidewalls. This will eliminate potentially non-code compliant conditions and provide an unobstructed view for the spectator and not hinder the operation of the bleacher. Also verify the minimum applicable building code clearance required above the last deck or last row seat. A distance of 2.5 inches from the end of the bleacher or end rails to the wall or obstructions is generally recommended. Operating clearances are required between manually operated sections or at end of a bank of seating if located adjacent to a wall as shown here. This dimension may vary depending on the number of rows, but in wall-to-wall applications, when rails are not provided, the clearance to the wall or obstructions should never exceed the 4-inch code required maximum width. Floors should be able to withstand a concentrated point load per square inch that varies by the system size and quantity of structural sections. Synthetic floor surfaces should be static load tested to determine suitability. Wood floors should be solid blocked under the bleacher supports. Section 2. Bleacher types. There are 5 specific types of telescopic seating systems widely available. The type of facility and budget you are planning will help you determine which best meets your needs. Wall-attached, forward fold is the most common and economical type of telescopic seating. Typical construction for this application may include block walls and poured concrete walls. In this typical application, the bleachers open in the forward direction. They are commonly available up to 30 rows and utilize either wall attachment and/or floor attachment. They may be specified with either manual or power operation. Rear cutouts may be necessary to accommodate column projections and other obstructions. Standard sections offer best economy. Individual sections make up banks of seating. For cost efficiency, use standard section lengths and minimize the number of sections in each bank. For example, a 100-foot bank of seating may consist of 4 25-foot sections. Code compliance and all load testing data is based on the longest possible section lengths. Certain wall requirements should be taken into consideration. Ideally, the walls to which the seating will be attached will not have column projections or other obstructions greater than 1.5 inches. When columns extend further than 1.5 inches into the room, it is recommended that the seating be cut out around the column rather than installing in front of the column and filling the space to the wall, or employing back rails. Both of the methods are more expensive and require more extended dimension than the cutouts. At column cutout locations, structural supports are added to ensure the deck surface is properly supported. Plywood decks are scribed tight to the columns to eliminate all gap openings. Recessed telescopic seating systems require minimal clearance to fit conveniently under a balcony overhang. Typically, a recess is created by extending the balcony over the main floor and using this space as storage for the retracted telescopic bleachers. The purpose is to achieve more balcony space and more usable main floor space when the system is fully retracted. Available with various seating options and typically up to 30 rows. With the proper engineering, the unit can be closed nearly flush with the back wall, allowing the stacked bleacher to be contained completely under the overhead walkway. A recessed system utilizes extra rows of understructure linkage or scissor mechanisms in order for the bleachers to stack under the balcony. It is important to note that recessed system stack dimensions are larger than wall-attached systems. The recess opening or clearance between the top of the last row seat and the underside of the recess is recommended to be approximately 3 to 4 inches, but can be as small as 1.5 inches. Since the recessed units can serve as access to the balcony seating, it is necessary to coordinate the balcony height with the height of the last row of seating. Recent building code changes allow for step heights to vary as you transition to adjoining construction if properly marked with contrasting step colors. These tolerances may be unachievable and code variances may be required. Please consult the manufacturer for design assistance. Reverse fold systems are designed for applications where space behind the bleacher stack is desired for other activities when the bleacher is not in use. This is common in areas such as mezzanines or balconies. Typically, up to 18 rows can be specified with this type of system. Reverse fold units are frequently seen in balconies, but can also be used on the main floor. This type of application is mounted to the floor at the first row, and the entire unit moves in a reverse direction until fully extended. These units create a natural wall to separate areas. Since reverse fold systems are generally located away from a permanent wall, back panels and back rails are required for spectator safety. The standard height of the back panel is 8 feet. The back rail design shown here contains vertical intermediate members to eliminate ladder effect. Proper roll rise is important to achieve adequate sight lines. 11.5-inch or 16-inch rise is recommended for optimal sight lines on balconies. Less than an 11.5-inch rise does not provide wide-scope vision of the main floor activities. An aisle recovery system is an option that can be provided to create a front aisle space when the seating is open and close over this aisle when the seating is in the stacked position. Aisle recovery will allow the entire stack to move forward and capture space behind the system. Typically, a maximum of forward travel can be achieved utilizing aisle recovery. This option is not available with truncations. Also note that longer forward travel will increase stack size. This is achieved by a concealed mechanism under the lower rows. The freestanding floor-attached method is an option when wall construction or building shape won't allow you to attach to the wall. In these cases, there are systems that attach to the floor. Applications may include metal walls or round buildings. Similar to wall-attached units, freestanding systems are permanently attached to the floor only. It is very important to verify that the flooring is suitable to anchor the rear row vertical posts of the bleacher. When freestanding units are located away from a wall, back panels and rails are required for safety purposes. The standard height of the back panel is 8 feet. Typical freestanding system guidelines are 20 rows at 10.25-inch rise, 17 rows at 11.5-inch rise, and 12 rows at 16-inch rise. Always contact the manufacturer for additional information specific to applications requiring more than 20 rows, and note that larger stack dimensions may be required. Mobile systems consisting of single sections of bleachers up to 21 feet wide can be used in one part of a building and stored in another on the same floor level. They offer increased flexibility since these are independent, self-supporting units that do not require anchorage to either wall or floor. Typically used in the gymnasium, music room, cafeteria, and classrooms, they provide the ultimate in flexibility along with easy manual operation. Manufacturers offer them with various seating surface options, typically up to 14 rows at 10.25-inch rise and 12 rows at 11.5-inch rise, and all available back-to-back seat spacing. Portable hydraulic dollies are required for transportation of units up to 14 rows to and from various spectator or storage areas. Hydraulic trucks are required to move mobile units. They are freestanding. One pair may be utilized for moving multiple sections. The row limitation on wood or concrete floors is a maximum of 12 rows with an 11.5-inch rise, or 14 rows with a 10.25-inch rise. On synthetic floors, a maximum of 9 to 11 rows is recommended for convenient handling. With proper planning, the desired seating capacity can be achieved without oversized mobile units that can be difficult to handle. Back panels and back rails are required by code for safety purposes. The standard height of the back panel is 8 feet. When the units are open or closed, back panels provide a flat wall surface and discourage access to the understructure. The back rails shown on this unit contain vertical intermediate members that eliminate the ladder effect and discourage climbing. Today, the most popular bleacher seating surface is plastic. Seat contour designs and construction grades vary by manufacturer. The plastic seat modules shown here offer high durability. These particular modules are contoured for added spectator comfort, available in 10-inch or 12-inch depth, and a full 18-inch width. They are constructed of one-piece injection molded high-strength polyethylene which resists stains and will not splinter or warp. The molded in solid color will not fade or wear out. Manufacturers have varying methods of attaching the plastic modules to the deck. In the example shown, a specially designed attaching clamp provides maximum rigidity with steel-to-steel connection of the module. Here each module incorporates full half-inch perimeter interlock to secure one module to the next for increased strength. 5 vertical and 2 lateral ribs inside each module provide increased strength and are positioned for easy cleaning. Classic wood bench seating is typically constructed of 3/4-inch grade B and better southern yellow pine with a clear polyurethane coating. These wood seats and front riser boards are finished in classic style to enhance the appearance of the gymnasium or field house. Platform chairs can be mounted on the telescopic understructure to create a VIP seating area. Manufacturers offer them with manual or semi-automatic operation. They are only available with back-to-back spacing of 30, 32, or 33 inches. Section 3. Code Compliance. Every bleacher configuration must conform to applicable code requirements for center aisles, center aisle rails, intermediate steps, back panels and back rails, along with safety end rails. Aisle center rails are installed on alternating rows and are required by all building codes for spectator safety. There are multiple types including folding, which are permanently attached, fold over and store on the deck when not in use. Removable, also store on the deck when not in use. Both folding and removable require labor to set up and take down each rail. Permanently attached self-storing aisle center rails, as shown here, are fully automatic, eliminating all setup labor. This particular design is fabricated from round tube steel for safety by eliminating sharp edges that could pose hazards to patrons. This design also has no significant protrusion from the bleacher stack when in the closed position, which promotes a safer environment. Another significant advantage is that they are fully automatic and make setup and takedown much faster and easier for facility personnel. The rails are permanently attached to the bleacher and automatically move into position when the unit is extended, eliminating labor and setup costs for the facility. Intermediate steps are required by all current building codes to provide an equal depth and height foot surface between rows. Safety abrasive tread is provided on all steps for additional spectator safety. Intermediate steps are securely mounted to provide a firm walking surface. If columns protrude into the last row walkway, additional aisles may be required for code compliance. Safety end rails are required on open ends of telescopic seating systems. These are available in self-storing and removable types. The self-storing end rails, shown here, offer safety with convenience. Each end of self-storing end rails typically requires 16 inches to 18 inches of clearance to walls or obstructions. The rails mount to the underside of the deck with additional supports attaching to the rear riser and nose beam. This eliminates all setup labor. Removable end rails mount into sockets attached to the rear of the deck support. Rails may be folded and stored in the retracted bleacher. Typically allow 5 inches of clearance to any obstructions for removable end rails. Back rails and back panels are used on mobile bleachers and freestanding and reverse fold units when positioned away from adjoining construction to provide added safety and close-off access to the understructure. Well-designed back rails contain vertical intermediate members to eliminate the ladder effect. When the units are open or closed, back panels discourage access to the understructure and improve aesthetics with a flat wall surface. Most standard back panels are provided in 8-foot heights. Section 4. ADA Requirements. Manufacturers have many available provisions to comply with ADA. You can engineer flexibility into your ADA compliance by considering some of the following options. Shown here, a standard 36-inch wide, 1-row deep permanent single notch out at the end of the seating bank. A 1-row deep permanent double notch out with optional front rail. A double 1-row deep recoverable notch out shown in ADA mode. The same double 1-row deep recoverable notch out shown in recovered mode. Locations of single and double notch outs are determined by the understructure component layout. Shown here is one engineering design available to accomplish this transition. Here, a horizontal rod engages a vertical pin linkage that locks the system in place in either recovered or handicap positions. Recovered 1-row deep seating truncations are available to accommodate larger groups of people or team seating. The amount of handicap seating required will depend on total number of seats and the applicable codes. ADA code requires that these seating locations be evenly dispersed throughout the seating area. Section 5. Optional accessories. Vinyl side curtains are available to close off the ends of the bleacher when in the extended position with a heavy-duty laminated vinyl. Grommets are available at every hangar location and incorporate a chain-weight bottom hem. They are available in many colors. If there are doorways at seating bank ends, vinyl side curtains can provide a vertical barrier which may be required by applicable codes. End panels are available to close off the opening behind the rails of the stacked bleacher. The style shown here is constructed of half-inch poly-coated plywood with aluminum edge trim. Other styles and grades are available from different manufacturers. Backrests options are available in manually raised and lowered wood or plastic with manual, semi-automatic, or fully automatic operation systems. The style shown here features fully automatic operation. These backrests store by the closing operation of the bleacher. Each row of backrests are raised and lowered with absolutely no labor required. A concealed spring mechanism eliminates any pinching hazard. Ergonomically designed with greater spectator comfort, these backrests are 18 inches wide and available with 30, 32, and 33-inch spans, requiring 11.5-inch rise. Specifying the correct power system to operate the system smoothly and efficiently is important. There are two basic types of systems. Friction power systems, typically used with bleachers up to 26 rows, incorporate friction drive rollers as an integral part of the first row assembly. The number of motors and friction rollers will vary by number of rows requiring operation. In the large seating system shown here, multiple roller assemblies were required. Most typical bleacher banks have two friction roller assemblies linked together by a continuous drive shaft driven by a half horsepower 208-volt three-phase motor per structural section and spaced apart to overcome minor variations in the floor surface. This continuous drive shaft controls drive roller operation in a straight, efficient manner, especially important on bleacher banks which include numerous notchouts or truncations. An important safety-related accessory that may be added to a friction power system is a motion monitor. This device is designed to send an audible and visual alarm signal prior to the bleacher operation. A built-in delay allows patrons or facility personnel to move away from the bleacher before movement begins. A non-friction power system is a fully automatic power system designed to open and close while attached recessed or reverse fold telescopic bleachers without the need for traction force on the floor. Typically used for higher row or synthetic floor applications, it has the capacity to move more rows of bleachers than other mechanical power systems and incorporates 16-inch long chain drive pusher links for dependable performance as well as non-slip straight line operation. Both friction and non-friction power systems are connected to the first row of the understructure. These power systems, along with the components and design of the understructure, play a key role in the overall telescopic bleacher system reliability, longevity, and feeling of stability experienced by spectators. The bleacher manufacturer should be able to assist you in properly specifying a power system strong enough to hold up to years of use. Section 6. Understructure. As an architect, you want to recommend a system that is going to provide reliability for your customer, their patrons, and setup and maintenance personnel. As you consider various bleacher designs, you'll want to look for components that add longevity. Here are some examples. Row locks. These stabilize the bleacher under load in the extended position by securely locking each support post to an adjacent post. They automatically engage and release for the opening and closing operation. Individual row locks make it possible to open any number of rows without opening the entire bank of bleachers. These are positioned on a number of beginning rows depending on the overall size of the seating bank. Guidance systems, such as the one shown here, are a low-friction, flexible rod system that assures positive engagement of vertical supports without binding for smooth operation over uneven floor conditions. It maintains proper vertical column spacing, reduces wear, and helps eliminate what is called racking damage. Deck supports help prevent sagging and potential binding during operation. Adding stability, they play an important role in the patron's feeling of safety and security as well. If the understructure employs nylon rollers at the top of every deck support as shown here, friction is minimized for smoother, quieter operation, and the steel-to-steel contact, which could otherwise hinder the operation of the bleacher, is totally eliminated. Sway braces fabricated from steel are essential for bleachers to resist the compression and tension forces created when the bleachers are loaded. The overall number of sway braces are determined optimally by 2 per row per section. A well-engineered understructure, when properly maintained, will greatly enhance the lifespan and performance of the bleacher. Section 7. Coordination with other trades. Communication is important to ensure the bleacher you specify is a trouble-free part of the project. Coordinate solid blocking under the bleacher support locations with the wood floor supplier. Wheel travel layouts can be provided to ensure the proper location of the wood blocking. Also coordinate the installation sequence of the telescopic seating system with the floor supplier. Options include a complete floor installation with proper finished court lines before the bleacher is installed, or the bleacher installation can be completed prior to painting of game lines and top finish coats. Coordinate the bleacher's electrical requirements with the electrical subcontractor. For instance, a minimum of 1 junction box must be provided for each bank of power to be located per the manufacturer's instructions. The electrical contractor must furnish and install conduit, wiring, and junction boxes. The electrical contractor shall perform the connections to the seating equipment at the safety disconnect. Motors, typically 208-volt 3-phase, housing and wiring shall be installed by certified personnel. Coordinate balcony gate locations if applicable with the bleacher aisle layout. Identify gate locations and sizes. Identify balcony rail dimensions and mounting. To ensure code-compliant transition into balconies, coordinate balcony heights with the bleacher structure heights. Section 8. Review. In this course, we have listed and illustrated a glossary of terms common to the bleacher industry. We've covered telescopic seating system design considerations. Bleacher types, such as wall attached, recessed, reverse fold, freestanding floor attached, and mobile bleachers. Learned about common seating surface options and discussed applicable codes pertaining to aisles and ADA requirements, such as end rails, aisle rails, intermediate steps, end curtains, power systems, and backrests. You learned some basic components of the bleacher understructure, and we pointed out important considerations for coordination with other trades. Thank you for your time. This concludes the American Institute of Architects Continuing Education Systems Program. This presentation is protected by U.S. and international copyright laws. Reproduction, distribution, display, and use of the presentation without written permission of the speaker is prohibited.